So far we have talked about decision trees in the case of classification. Let us look at how decision trees work in case of regression. Now in case of classification, what we saw was we had independent variables and we had dependent variables which took different labels. For example, in this we have pluses and minus. And how did we create our splits? The decisions were based on splits which minimize the value of Gini index. This is what we saw for classification. Now in the case of regression, things will be a little different because we will no longer have the concept of pure and homogeneous buckets. So the concept of pure and homogeneous buckets, they are only applicable in case of classification, where we try to create buckets which has only the pluses or ones and buckets which have only the minuses or zeros. So that is the concept of homogeneous bucket. But in case of regression, we don't have the concept of homogeneous buckets, as our dependent variable y is just a continuous variable. So for example, income or price of a house. So this is the only dependent variable that we have, and there is no concept of labels here, and so the concept of homogeneity or purity will not apply. So we will no longer use the Gini index in this case. Then how do we create the splits? Decision tree will always create a split. We will always make decisions and create splits. So how do we create splits in case of regression then? So what we do in case of regression is we create splits in such a way that it minimizes the sum of squared error in each bucket. So just like in linear regression, where we try to minimize the sum of squared error by drawing a line, in case of a decision tree for regression, we try to create a split, or we take a decision in such a way that the two buckets that are created after a split have the minimum value of sum of squared error. So if we have, let's say if we have points like this, we have 3 points here and 2 points here, and if we create a split at this point, what this would mean is the sum of squared error of the bucket B1 and the sum of squared error of the bucket B2 are minimum. Any other split if we had created, let's say if we had created splits at this point, the sum of squared error of this bucket would and sum of squared error of this bucket would have been higher than what it is currently. So this decides where splits are made in case of regression. And what do we predict? What do we predict? In decision trees for classification, we saw that we were predicting the probabilities. So if we had 3 pluses in one bucket and 1 minuses in the same bucket, we would predict 3 by 4 as the probability of plus, and we would predict 1 by 4 as the probability of minus. And then using a threshold, we used to convert them to ones and zeros by using a threshold. We had the option of taking a threshold of 0.5 by using method is equal to class while building our model. Now in this case, the concept of probability will not apply because this is regression. So in this case, what would we predict then? We will predict the average of the points in the same bucket. So let's say we are discussing an example of the Boston data set where prices are represented by some continuous value. So we have 3 houses in the same bucket, 1, 2, 3 here in bucket B1. So what we would finally predict is we'll predict the average of all the 3 houses. So the prediction for each of these houses, let's say this is house 1, house 2 and house 3. So house 1, house 2, house 3, their actual values might be something like this. So this might be their actual values. What our prediction from a decision tree will be? It will be the average of all the 3. So it will be 10 plus 12 plus 14 divided by 3. So it will be 12. So I'll predict 12 for this house. I'll also predict 12 for this house, and I will also predict 12 for this house, and so on. Similarly, the average of this bucket for these 2 points. So if these are 4 and 5, so 4 and 5, let's say their values are 10 and 20. So I'll predict the average of 10 and 20 in this bucket, which is 15. So 15 for this house as well as 15 for this house. So this is our actual, this is our predicted. We can then go ahead and find the error parameters that we usually do in regression. So we can find the RMSE, we can find the mean absolute percentage error, and so on. This is how we make splits for a decision tree in case of regression.